We're told that a particle's position along the y-axis is measured by this function y below. And then we're asked to find where the particle is speeding up and where the particle is slowing down. So we have to prove where both of those are happening. Now, one thing that I think it's important to note is what do we even need to look for if we're trying to find speeding up and slowing down? And so we know from today's lesson that a particle is speeding up. We know that something is speeding up when the velocity and the acceleration have the same sign. So they're both positive or they're both negative. Have same sign. And then we know that it's slowing down. I'll write this on this side. We know that we're slowing down. And maybe I'll write this in a different color. We're slowing down when our velocity and our acceleration have different signs. So one is positive and one is negative. Have different. Signs. All right, so in order to figure out if either of those are true, we need to find the velocity and acceleration. This function right here gives us position. And so we need to find velocity and acceleration. We know that velocity is the derivative of position. So finding that derivative, we get that to be 3t squared minus 24t plus 45. And then we also know we need acceleration, which we might remember is the derivative of velocity or the second derivative of position. And in this case, I'm going to scooch this over a little bit. There we are. In this case, we're going to get that that is equal to 6t minus 24. All right. Now what we need to do is we need to find our critical points and our candidates for points of inflection. Critical points come from here because that is when the second derivative, that's when the first derivative equals 0 or when the first derivative is undefined. Here, there's no point that it's undefined, so we can just say 0 equals 3t squared minus 24t plus 45. I see here that everything's divisible by 3, so I'm just going to divide it all by 3. So I get 0 equals t squared minus 8t plus 9. And so I need to think, what are two numbers that when multiplied together become 9, but when subtracted from one another become negative 8? And I know that that is going to be t minus, what is that going to be? Oh, I did this wrong. It's not 45. That's 40. That's 45 is 45 divided by 5 is 9. It's actually 45 divided by 3 is 15. Ooh, caught my mistake there. Okay, so we need to figure out two numbers that add up or multiply to make 15, add together to make negative 8. I know that that's going to be t minus 5 and t minus 3. Whew, there we go. Okay, now what do we do next? We just use the zero product property, so I know that t is going to equal 5 or t is going to equal 3. Great. Now on the other side, I see that I have my second derivative. We want to find here, we're finding our candidates for points of inflection. And to do that, again, we set it equal to, or we set the second derivative equal to 0. So 0 equals 6t minus 24. I'm going to add 24 to both sides, divided by 6, so I get t equals 4. All right, so I have three numbers, 3, 4, 5. So those are going to be the different barriers in my interval that we have. The next step that we need to undertake is we need to create our double sign chart here in order to figure out where are these things happening. So we have our function t. We care about the velocity, the sign of the velocity, and we also care about the sign of the acceleration. And so I'm going to extend these. I want to know these in order from least negative to most negative, my critical points and candidates for points of inflection. And I see that that's going to go 3, 4, 5. And so we go from a negative infinity to 3, and then 3. And then 3 to 4, 4, then 4 to 5, 5, and then 5 to infinity. So these are all the intervals that we're going to check in. What's happening to our velocity? What's happening to our acceleration? We also want to mark down where velocity is 0 and acceleration is 0. We know that velocity is 0 at 3 and 5. So I'm just going to mark those there. And I know that acceleration is 0 at 4. And that's from the work that we already did up here. And so from negative infinity to 3, what's happening to our velocity? I'm just going to, we can pick 0 because 0 is in the interval. If I plug 0 into my velocity equation, 3 times 0 squared, that's 0, minus 24 times 0, that's 0, plus 45, that's going to be positive, so I know this will be positive. And then I see that it doesn't change from 3 to 5, so I can use 4 and plug that in. I'm going to plug in 4 here for t as an example, and I'm going to erase it in a moment. 4 minus 5 is negative 1. 4 minus 3 is positive 1. That means this is negative. I'm going to rewrite this as just a plus sign. And so I know this will be negative, so it'll stay negative this whole region. Like I said, I'm going to erase this. And here, if we tested a really big positive number, really, really big positive numbers are just going to make this whole thing positive, because it'll be positive times a positive, so we get, oh, for the parentheses there, we got positive. Okay, great. Now what is happening to our second derivative? Well, we can test 3 as our value here, so let's try that. 3 times 6 is 18. 18 minus 24 is a negative number, so all of this will be negative. And what if we test a number in the other interval? Let's test from 5. We can just test 5. 6 times 5 is 30. 30 minus 24 will give us a positive number. So this whole thing is positive. Now, we're not done. We need to figure out when are we speeding up and when are we slowing down. Again, we're told that the particle is speeding up when v of t and a of t have the same sign. And so, where is that true? I see here we have 2 negatives, and here we have 2 positives. So that tells us that we are speeding up. I'm going to write this here. The particle is speeding up on, and we just named the intervals, on 3 to 4 and 5 infinity, because v of t and a of t have the same sign. Alright, and when are we slowing down? We wrote, and we know that we're slowing down when they have different signs, so let's find where that's true. Okay, I see that's happening here. And here. So, we know that we're slowing down on these 2 intervals, and we want to write this out. I'm going to scooch this over just a little bit so I can write this. Actually, I'm going to scooch it over a lot bit, shrink it. There we go. Okay. The particle is slowing down on, and I see it's happening negative infinity to 3 and 4 to 5, because v of t and a of t have different signs. And so there we have it. This right here, let me expand this just a little bit so you can see it all. We were given the position function, and then we used that to find our velocity and acceleration functions, and then we used what we know about these functions to figure out when is our particle slowing down and when is it speeding up.